Hi, grade 6. This is a math video for lesson 4-5. Today's lesson starts with problems where we're supposed to graph what we see up here. This is the problem y is greater than -3. I'm supposed to graph it on a number line. And so I'm going to put number -3 right in the middle of my number line. And then I'm going to put two numbers on either side of it. Now remember, on the negative side of a number line, things are reversed. And so this number would have to be -4, and this number would have to be -2. Now, think about this for a moment. What would be a number that would make this a true statement? What number is greater than -3? Isn't that all of the numbers that are on this side of -3? You betcha. So I'm going to shade the right-hand side of this line. And then I have to decide what kind of circle am I going to put at -3. I'm going to put an open circle at -3 because I don't want to include -3 as part of the solution. But I do want to shade everything to the right because -2, -1, 0, 1, 2, and 3, and 4 are all numbers that would make this a true statement. Let's look at this problem. I'm going to draw a number line. I'm going to put 2 in the middle. I'm going to put 1 here and 3 here. Give me a number that makes this a true statement. Well, how about 5 or 4 or 3? Again, those are all numbers that are to the right of the number 2. So I'm going to shade to the right of the number 2. Also notice I use an open circle because it says greater than. I can't put 2 here. 2 is not greater than 2, so I don't want to include 2, and that's why I use the open circle. Let's look at this one right here. This symbol is a little bit different, isn't it? This time we have the symbol greater than or equals to, not just greater than. I'm going to put 0 on the left and 2 on the right. And give me a number that's bigger than 1, a number that's greater than 1. Again, we're going to be shading to the right. But this time, I'm going to use a filled-in circle. Why? Why do I use a filled-in circle instead of an open circle? I use a filled-in circle because this time the number 1 can be a solution to this problem. 1 can be equals to 1. This really says b is greater than or equals to 1. b is greater than or equals to 1. So 1 is part of the solution, and so is 2, and so is 3, and so is 4. So I fill in the circle this time, and I shade to the right. Let's go to this one right here. Again, I'm going to draw a number line. I'm going to put -5 in the middle, -6, and -4. What are some numbers that are bigger than -5? That would be the numbers to the right again. Boy. And I'm going to use a filled-in circle because I also want to include the number -5 in my set of answers. -5 is greater than -5 is greater than or equals to -5. -4 is greater than or equals to -5. -3 is greater than or equals to -5, and so on. Let's go down. How about q is less than -2? q is less than -2. Well, that would be -3. That would be -1. What are some numbers that are smaller than or less than -2? That would be the numbers on the left side of -2. So this is my first time shading the left side. I'm going to use an open circle at -2 because I don't want to include it as part of the answer. And there's my solution for that one. How about x is less than 2? Again, I'm going to put 2 in the middle, 1 over here, 3 over here. This is going to be a case where I shade the left side again. And this is going to be a case where I have an open circle because I do not want to include 2 as the answer. Now, what if I did this? What if I made it x is less than or equals to 2? Then I would fill in the circle, because then 2 is less than or equals to 2. So, to review, if you see this symbol or this symbol, you're going to use an open circle. But if you see this symbol or this symbol, you're going to use a filled-in circle. Okay? Might want to write that down somewhere. Open circle with less than or equals, filled-in circle with less than or equals, excuse me, less than or greater than, rather. Filled-in circle when it says less than or equals to or greater than or equals to. What about these problems when we're told to look at the problem and then solve it? Well, it's just like the previous day's assignment, except now we have inequality symbols instead. We're going to leave some space. We're going to write the symbols down the middle. We're going to divide by 3. And we're going to get a value of t being less than or equals to 5. How about this one? Well, we're going to write the symbols. We're going to write the problem, but we're going to leave some space. We're going to add 7 to both sides, and we get an x value of -1. I'm sorry, an x value that's less than or equals to -1. Here, I'm going to write some less than symbols. I'm going to write the problem. I'm going to do the opposite of adding 12, and I get an a value that is less than -4. How about here? Going to write the symbols. Going to write the problem, but I'm going to leave some space. Going to do the opposite of adding 4, which is subtracting 4. And I get a t value that's greater than or equals to -10. Here, I'm going to write the symbols. I'm going to write the problem, but I'm going to leave some space. I'm going to subtract 4 from both sides. I get an a value of 6. How about this one? Oh, I'm going to write the symbols, write the problem, but I'm going to leave some space. I'm going to subtract 5 from both sides, and I get a c value that's less than 4. Here, I'm going to write the symbols. I'm going to write the problem with leaving some space. I'm going to add 1 to both sides, and my d is greater than or equals to 9. And I'm going to write the symbols. I'm going to write the problem, but leave some space. I'm going to add 11 to both sides, and I get a g value that's greater than 13. This is the kind of work you're going to see today. Thank you, 6th graders.